Hey, once again, afternoon Form 1 class. I'm going to be taking you through manipulation of fractions into percentage, as well as finding an equivalence of a fraction. And then with that in mind, we are going to see how it extends to addition and subtraction of fractions. I hope you find this interesting. Let me start with the first question. We are asked here to convert this set of fractions into percentages. So if we look carefully there, um, we are given a number of fractions which, if we are to do a conversion to percentage simply means multiplying by 100. So let me try the first one. If I look at what I have on A, it's a multiplication of 1 over 2 by 100. And we know 100 divided by 2 will give us 50. So because we want this as a percentage, that symbol is important. We move on to question B, where we have got a fraction 2 over 5. We are multiplying it or converting it into a percentage, so we multiply by 100. Then we check how many times 100 is divided by 5, and we'll say 5 into 5, that's 1, into 100 is 20. Then if we say 2 times 20, that will give us 40. So it means 2 over 5 as a fraction, if we are to convert it into its equivalence percentage, it's going to be 40%. Now I'm on the last one, which is C. C, I have a fraction 3 over 25. So if I'm interested in converting it into a percentage again, I'll as well multiply that by 100. Then we check 25 into 25 is 1, because 25 and 100, they are multiples of 25. So if I divide 100 by 25, again, it will give me 4. Then 4 multiplied by 3, that will be 12. And remember, we are being asked to give our solution as a percentage. Right, so that's all on the first problem. The next one, we're interested in writing uh, fractions which are equivalent to the given. So if we want equivalent fractions, we're going to take advantage of natural numbers. And for natural numbers, we have 1, 2, 3, 4. The list goes on. In other words, we are saying all positive whole numbers. Then we exclude 0, because 0 does not have a sign. So you can just pick any. But now the problem is when we pick a number, it has to be in fractional form, which is equivalent to 1. Say, for instance, I want to use 3 to find an equivalence of 4 over 7. I'm going to say 4 over 7 because I don't want this fraction to change or multiply it by 1, but that one is going to be 3 over 3. So when I do the product, 4 times 3, it gives us 12, over 7 times 3, it gives us 21. So what it means is these two are equivalent of each other, because if we look at 12 over 21, we can simplify it using the HCF, which is going to be 3 there. So let me do the same for B. When I'm on B, I have a fraction 2 over 9. And this time, let me try use 5 to get the equivalence. So 5, if I want it to have the same value as 1, it's going to be 5 over 5. So if I multiply numerators themselves, that's 2 times 5, it will give us a 10 over 9 times 5, that's 45. So in essence, we are saying 2 over 9 there is equivalent to 10 over 45. Now moving on, this time around I'm adding fractions. So I'm going to start with the first one where I have 2 over 3 plus 1 over 9. And remember, when we are adding or subtracting fractions, if the denominators are the same, we simply take that denominator and we simplify what's on the numerator. Now, if I look carefully on my denominators, I have 3 and 9, and both are multiples of 3, meaning I can have this first fraction in equivalent form with a denominator 9. So if I'm to do it somewhere separate, I can say 2 over 3. If I want it to be in its equivalent form with a denominator 9, I'll multiply by 3 over 3. So this will give me 2 times 3, that's 6 over 3 times 3, that's 9. So what it means is 2 over 3 is equivalent to 6 over 9, and then I add 1 over 9 according to the question. That I was doing it so that I have a common denominator of 9. Then I simply simplify what's on the numerator, the 6 plus 1, giving me 7. Then I move on to B part, where I've got a similar scenario again. I have a fraction 3 over 4 plus 1 over 8. And if I check carefully on my denominators, both these two are multiples of 4, implying that I can turn the first one into its equivalence form where the denominator will be 8. So I'm going to say equal to here. So if I take, let me just do the calculation aside, I have 3 over 4. If I want my denominator to be 8 without changing anything, I'll multiply both numerator and denominator by 2 over 2, which is equivalent to 1. So that's 3 times 2 giving us 6, 4 times 2 giving us 8. So those two, 3 over 4 and 6 over 8, they're equivalent, meaning I'm allowed to say 6 over 8 plus 1 over 8. And once the denominator is the same, I simply take that common denominator. Then I add the fraction, the numerator 6 plus 1 should give me 7. So moving on, I'm now on subtraction, and subtraction is nothing much than the addition that we did. It's just the opposite. In other words, addition and subtraction, they are opposite of each other. So let me try the first one. I have 5 over 6 minus 1 over 3. We call it A. But if I check again, it's similar scenario. 3 and 6 are both multiples of 3. So I can have this in equivalence form where the denominator will be 6. So to get the 6, I'm going to say 1 over 3 multiplied by 2 over 2 because I don't want to change the meaning of the fraction. So 2 over 2 is the same as 1. So, but in real terms, if I multiply 1 and 2, it will give me a numerator of 2. I multiply 2 and 3, I get 6. So we will come back to say 5 over 6 minus, in equivalence form with a denominator 6, it will be 2 over 6, implying that our final answer, since the denominator is the same, which is 6, I simply simplify the numerator 5 minus 2, which will give me 3. But I'm not allowed to stop there because 3 over 6, we still see that there's an HCF, which is the biggest number that can divide both numerator and denominator without leaving a remainder, which happens to be 3 for this case. So we can use it to continue dividing both numerator and denominator by 3. So 3 divided by 3 on the numerator gives us 1. 6 divided by 3, it will give us 2. So that will be our final answer. Let me move on to B. B, I have got 11 over 12 minus 1 over 4. Again, if I check 12 and 4, they are both multiples of 4. So I'll need to convert this into its equivalent form with a denominator 12. So to do that, I'll say 1 over 4 multiplied by, because I want my denominator to be 12, I'll multiply by 3. But because I don't want the sense of the fraction to change, I'll say 3 over 3, which I know gives me a 1. And when I do so, I'll come to say here is 11 over 12 minus. When I multiply 3 by 4, it gives me 12. I multiply 3 by 1, it gives me 3. Then I know I now have my common denominator 12. Then it will be 11 minus 3, it gives me 8. And once again, we don't stop here because we can simplify further to say 8 over 12. 8 and 12, they have an HCF of 4. So I can divide my numerator by 4, it gives me 2. I divide my denominator by 4, it gives me 3. I think that was it for question number 4. Moving to question number 5, which is our last one. Um, Convert percentages to simplified fractions. So we have got 20%. Now we are doing the reverse. We know the percentage form sign, it came from multiplying a fraction by 100. So this time around, if we want to revert, it means we go the opposite of multiplication, which is division. So for first part A, 20% is the same as 20 out of 100. Now, what we'll do here is we look for the HCF of 20 and 100. Now, because these two are multiples of 20, so 20 becomes the HCF. So on the numerator, we say 20 divided by 20, the result will be 1, and 100 divided by 20, it will be 5. Then we'll be done with the first one. Moving to the second one, which is 80%. If I say 80 over 100, that's converting a percentage to fractional form. And once again, 80 and 100, they are multiples of 20, implying that 20 becomes the biggest number which can divide both numerator and denominator without leaving a remainder. So if I divide my numerator 80 by 20, I get 4. Then I divide my denominator by 20, which is 100 divided by 20, I get 5. Then the last one, C, I have 125%. Percent, we said it means out of 100. Now, this time around, if I look at 125 and 100, they're no longer multiples of 20. Rather, they are multiples of 25, implying that our HCF has changed from 20 to 25. Hence, if I divide my numerator there, 125 by 25, the result is 5. And I divide 100 by 25, the result is 4. Then we are not allowed to leave our answer in improper form, where our numerator is bigger than the denominator. Rather, we'll be forced to do a conversion, which will give us a mixed fraction. In essence, we are going to test how many times 4 divides 5. It's going to be 1, remainder 1. That 1 is out of 4. I think that is all from the first series in our Form 1 class. Uh, Keep watching. You are going to receive similar problems that you find interesting. So below here, we have got extra questions that you can use to check if you fully understood the concepts that we described above. So there we are. I'm scrolling slowly so that the questions are visible. Then you can try them and see how far you can go. If you're struggling somewhere, you can comment on the section below, then I'll be willing to assist where possible. I thank you for this series.